Bismillahirrahmanirrahim. This is teacher Iman Al-Khaldi explaining some properties in permutations and combinations, which are two ways to count. Here in number 1 we say that n permutation r divided by n permutation r minus 1, that all will give you n minus r plus 1. And if we are going to have another ratio, but including consecutive for n and r, so we can have n permutation r 2 or divided by n minus 1 permutation r minus 1. And after proving this, you will get n. And the other side, which is talking about combination, you can call this number 3, and you can see that we have n permutation r over n combination r minus 1, and that can be given as n minus r plus 1 divided by r. Now if we're going to have another ratio with consecutive n and consecutive r, we will get n combination r divided by n combination or n minus 1 combination r minus 1. And that will give you similar to here, which is n, and divided by r as usual. Now let's go to another property, which is sum of consecutive r with the same n. Sum means we are going to add like this. Add n combination r with n combination r minus 1. We can notice that n are the same and they are consecutive like this. R are consecutive. So we are going to add 1 to n like this, n plus 1, and select the biggest r. Now we are going to have the difference opposite to the sum. Difference of consecutive n is coming from the rule of sum, exactly like this. If we have here n combination, watch it, n combination r plus n combination r minus 1 equals to n plus 1 combination r. If you're going to move one of them to the other side, for example, if I will move this one to that side, so I will have n combination, I will have n plus 1 combination r equals after subtracting n plus 1 combination r minus n combination r minus 1 will give you n combination r. How? Like this exactly. Here n combination r will stay, and we will have after equal this n plus 1 combination r, and then we're going to move this to the other side to get it negative and to change its sign to be n combination r minus 1. You can see that we have now difference. We have now difference between two consecutive n and two consecutive r. So the best way is you are going to select the smallest r. You have to select the smallest n, the smallest n is going to be here. So we select it. And then select the biggest r, which is this one. So you will get n and r. Now similar in the same rule, I can do not move this one, but I can move the other one. So I can write the question again, or that rule again, which is including n combination r from the sum, n combination r minus 1 equals n plus 1 combination r. I can now move this one, which is n combination r, and see what is left. Here I can have n combination r minus 1 stays equal after n plus 1 combination r minus n combination r. You can see that we have the same r here, nothing bigger than other, and you have consecutive in n. with difference. In this case, you are going to apply this rule. You have to select the smaller n, which is this one here, and then reduce your 1, or reduce your r by 1, like this, because we have the same r here and there. So reduce it by 1. And this is for difference, which is coming from this sum rule. Now, we have the most important rule, which is the reduction. Take care about it. Reduction formula, which can reduce the value of r if it is that big. For example, if you have n combination, or let's have numbers. For example, if you have 100 combination 99, you can't write 99 factors up and 99 factors down. This will be hard for you to evaluate or calculate. So it is better for you to reduce this 99 by subtracting 100 minus 99. So that will make it only 1. So it is better to write 1 factor up and 1 factor down. So it is allowed for you to reduce this to be n minus r, when if you have this r is bigger than half of the n. So you can use this rule to calculate or evaluate the value of combination. Here, equality formula. This equality formula is talking about if we have two combinations are equal to each other with the same n and different r. So we will have either r1 is equal to r2, and this makes sense, or if you add them, you will get n. And this will take you back to what we did here exactly. We said that 99, if you add it to that one, you will get that 100. And we said that if we're going to add r plus n minus r, you will get an up. So you can say that whatever you have down, if you add it to whatever you have down, you can get whatever you have up. Now the last note about what we discussed in the properties. We said that if you are talking about in permutation R and you want to expand it, you can see that in permutation R can be expanded in this way. Start by the biggest factor, which is n, then reduce it by 1 to get n minus 1, then reduce it by the next, and always we have multiplication between them, n minus 2, till you are going to finish till n minus r plus 1, which gonna come by subtracting this n by this r, then add it by 1. You can understand it more by numbers, like if I have, for example, here 10 permutation 5 or 4. Let's do it. We can write now 4 factors, which are starting by 10, then 9, then 8, then 7. These are 4. This is the first one, and this is the last. This we're going to call it the first factor. This is the first factor, which is the largest factor. So always the largest factor is going to be here, the largest factor, which is going to be similar to n. So n always is going to be the largest, like what is written here. The largest factor in the expansion of the permutation is that n. Now the number of factors are, by looking to here, we found that they are 4. So it will be r. So we're going to say that the number of factors is r. Now the smallest factor in the expansion should end by n minus r plus 1, which is going to be that number, which is 7. Let's apply it with that rule. Here we're going to say that if we have 10 minus it by 4 plus 1, you will get 7. So that makes sense. Thank you. Good luck.